Hello, geometry. Welcome to our next section, TC2, which we're going to talk about side lengths and angle relationships in triangles. So first thing we're going to talk about is the triangle inequality theorem, which is how we determine if given side lengths could even form a triangle. Now what I mean by that is if I have a really, really long piece of wood, say, like it's 10 feet long, and I have another couple pieces of wood. I have a 2-foot piece and I have a 3-foot piece. Could I make a triangle with these pieces? Well, it's pretty obvious that no, I can't make a triangle with them, because if I tried, the 2 and the 3, they wouldn't reach the end of that other piece there. Okay? So what is the criteria then for these two pieces to reach the end of that one? Well, the two smaller pieces need to add up to be bigger, the lengths of the two smaller pieces need to add up to be bigger than the length of the longer piece. That's what the triangle inequality theorem says. The two, well actually, we're going to generalize this even more. So we're going to say any two sides of a triangle will add up to be longer than the third. But since if we already have the one side is longer, we know is longer than the other two, then we can, we only have to check that the two smaller pieces add up to be bigger than the third piece. So in this case, we would say that A plus B is bigger than C. But the other inequalities are also true. If we said, like, if we added A and C together, that would be bigger than B. Now, C is already bigger than B on its own, so it's obvious that this one's true. But also, B and C would add up to be bigger than A, even though both of them are bigger than A on their own. But the important one here is that the two smaller pieces add up to be bigger than the third piece. That's what we need to check to decide if three pieces can form a triangle. Another way you can think about this is if you're trying to get from one location to another, from trying to get from A to B, it's going to be quicker to walk straight there than it is to walk in two different directions. So walking along the path of B and then the path of A is going to be longer than just walking along the path of C, right? So those two directions, those two different paths are always going to be longer than the straight path. So when I want to determine if the following side lengths could form a triangle, 8, 17, and 24 centimeters, I want to check, is 8 plus 17 bigger than 24? If I add 8 plus 17, I get 25, and yes, that's bigger than 24, so yes. So start by writing the two smaller measures, add them together, and check to see if that's bigger than the third measure. If I try out this one, 3 plus 3, is that bigger than 7? Well, 6, 3 plus 3 is 6. Is 6 bigger than 7? No. So this one is, these three side lengths can't form a triangle. Okay? These three side lengths can't form a triangle. The 3's don't reach the end of the 7. 41 inches, 7 inches, and 35 inches. Notice we're not always given the two smaller ones first, but we do need to add the two smaller ones first. So 7 plus 35, is that bigger than 41? Well, 7 plus 35 is 42. 42 is bigger than 41, so yes. Okay. Oops, sorry, not yes. All right, so then the other thing we can do with this triangle inequality theorem is we can find a range of possible values that a third side could be given two values. So given two sides of a triangle, set up an inequality to show the range of possible lengths for the third side. So here's where we don't know which is the biggest side. So here's where having those two other inequalities can be helpful. These two, if we treat them as if they're the biggest side, then we just need to see, all right, 3 plus 11 is 14. So that means since these two need to add up and be bigger than the third side, that third side has to be smaller than 14. Okay? That third side has to be smaller than 14, because if it's bigger, then these won't reach, right? Now, if 11 is the biggest side, well, we'll need 3 plus something. So this 3 plus 11 needs to be bigger than 14. So 14 is going to be smaller. Now, if I have, actually, let's write it like this. So 3 plus 11 needs to be, I'll use x. I'll use x. 3 plus 11 needs to be bigger than x. So when we simplify 3 plus 11, we get 14. Okay, so 14 is bigger than x. X is smaller than 14. If my other side isn't the biggest side, if 11 is the biggest side, then 3 plus x needs to be bigger than 11, and we can subtract the 3 to find that 11 minus 3 is, 8, not 7, it's 8. X is bigger than 8. So we're going to summarize this, since I had to subtract 3. We can summarize this with an inequality to say x is bigger than 8 and smaller than 14. So a compound inequality, x is greater than 8 and less than 14. And it's strictly less than, right? Because if they're equal to, then the two smaller sides are just going to lie flat against the third side and are not going to form a triangle. So these other two, we're actually going to do this a little bit shorter. Notice how in this one I added the two numbers, and in this one I subtracted the two numbers. So we're going to simplify this a little bit. X is bigger than the difference, so we put that difference on the less than part. So that went there, and then the 14 went on the big side. So x is bigger than the difference between those two numbers, 31 minus 28, and is going to be smaller than the sum of those two numbers, 28 plus 31. So if we subtract, 31 minus 28 is 3, and 28 plus 31 is 59. So x can be anything between 3 and 59, if those are the two side lengths. The closer the numbers are together, the wider this range is going to be, because if we think about like an isosceles triangle, these lengths are close together. You could imagine this angle getting smaller. These sides are getting closer and closer together. They can have a really, really small measure for the third side, or you could widen that angle, increase that angle, and this can get wider and wider and wider, and we're going to get a bigger and bigger and bigger third side. So this is a really, really big range here for how big that could be. And then this one, 24 and 7. On the lower end, we're going to subtract, and on the higher end, we're going to add. So x is between 24 minus 7 and 24 plus 7. So 24 minus 7 gets us 17, and 24 plus 7 gets us 31. So x is between 17 and 31. That third side could be anywhere between 17 and 31. Now the other theorem we're going to talk about today, the other piece of the puzzle for determining side lengths and angle relationships, because we haven't really talked about the angles yet, is that the smallest angle is always across from the shortest side. And the largest angle is always opposite the longest side. So if we know that the shortest and the smallest angle correspond, they're across from each other, and the largest and the longest, or the largest angle on longest side have that relationship, then we can put the angles in order from least to greatest without knowing what the angles are, just knowing what the sides are. So when I look at these side lengths, 17, 20, and 24, the 17 being the smallest, if I want to go from least to greatest, 17 being the smallest side, it's across from the smallest angle. So angle C is the shortest. Angle C is the smallest angle. The next biggest side is the BC, the 20 meters. So angle A will be the next biggest angle. And then the largest angle is across from the longest side. Angle B is the biggest. Okay. Now, one thing to note about how sides and angles are often labeled. If sides are labeled these lowercase a, b, and c, the angles are labeled capital A, capital B, and capital C, and they're always going to be across from their lowercase letter. So capital A across from little a, capital B across from little b, capital C across from little c. So another way to express this shortest side, longest side business is to say if we have like AC, or let's go from least to greatest. If AB is smaller than, I'm using inequalities here, is smaller than BC, is smaller than AC, well then this angle C is less than, so notice angle C is the side across from AB, and angle A is across from BC, angle B is across from AC. We can write them in order using inequality symbols too. So the reverse is also true. If we know angle measures, we can order the side lengths. Shortest side is always opposite the smallest angle. And the longest side is always opposite the largest angle. Now in this case, we only know two of the angles, but we can use the triangle sum theorem to find the third one. So we can find the measure of angle D by adding together the 59 and the 53, and then subtracting those from 180. So the measure of angle D plus 112 equals 180. So the measure of angle D is, we can subtract to get 68. So angle D is our biggest angle. So it's going to be across from our biggest side, EF. If we're going from, in this case, we're going from greatest to least. So our greatest side is EF. And that's bigger than the next biggest side is across from the next biggest angle. So here, 59 is our next biggest angle. So DF is our next biggest side. And then our smallest angle is 53, so the smallest side is DE, the side across from it. Okay, so we can decide on how big the sides are based on the angles. We can decide on how big the angles are based on the sides, and it doesn't require knowing the measurements. Like here, we don't know how long the sides are. This could be really small, this could be really big. But as long as we know the order of the angles, we can determine the order of the sides. Pretty cool. So that's that one. Let me know, or come to class ready with your questions, and we'll do some practice together in class. Bye for now.